Hello there, we are going to continue where we left off from the last video with dissociation. In the previous video, you were writing the equations for dissociation, which we will still do here, but with one more step. So the first thing we're going to do is we're going to write the dissociation of this compound, which is calcium nitrate. So we are going to start with that first, okay? And again, this is a solid, okay? And we are going to dissolve that in, we will say, water, okay? So we are going to write each individual ion. So the first one is calcium. And again, this will have a charge of +2. You can find that on your periodic table. It is aqueous because it is dissolved in a solution. And there is only one of them. So you can write a 1 here, or you do not have to write anything in front of it. Plus, the other ion is NO3, which is a polyatomic ion that you can find on the back of your periodic table. Again, if you do not have your periodic table, you can always look this up. This will have a charge of -1. And again, this is also aqueous because it is dissolved in a solution, and most likely that would be water. And we have 2 of them. So I have to put a 2 in the front here to make sure that it is balanced. Now the question is asking if 9.5 moles of calcium nitrate dissociate, that is a typo, dissociate in a solution, how many moles of NO3 ions, which is nitrate ions, will be in the solution? So we will have to set up a picket fence for this. So you are going to start with what they gave you, which is 9.5 moles of calcium nitrate, okay? And this is very similar to what we did with stoichiometry in terms of using the balanced chemical equation and the mole-to-mole ratios. And that's exactly what we're going to do here. So you know that the unit here is moles of CaNO3 so that also is going to go here. So I'm going to write moles CaNO3 Now, where do I get that number from? The balanced chemical equation. And again, there's a 1 there, okay? So I'm going to write a 1. And then I'm going to convert into what I want the answer to be in, which in the past, it's been usually a different type of compound entirely. This time, we're just converting it into an ion, but we're still using that same principle. So they're asking for nitrate ions. Well, if I look on this side of the equation, I have 2 moles of nitrate ions. Again, an ion is something that has a positive or a negative charge. Now we just have to solve for this mathematically. So you would do 9.5 times 2 divided by 1. So that's simply 9.5 times 2, which will give us 19 moles of NO3 minus 1, which is a nitrate ion. And that would be your final answer. So there's one example, and I'm going to do one more down here, okay? So if I have 3.6 moles of calcium hydroxide that dissociates in a solution, how many moles of calcium ions will be in the solution? Now, again, we're going to do the same thing. We're going to start by writing the equation for dissociation. Again, this is a solid, and we can say that we dissolved it in water. My first ion would be that calcium ion, which has a charge of +2. It is aqueous because it is dissolved in a solution, and we only have 1 of them, okay? Plus, we have the hydroxide ion, and again, the charge for something like that you would find on the back of your periodic table, and this would be -1. This is aqueous because it is dissolved in a solution. We can say it was dissolved in water. And if we look over here, we have 2 of them. So I have to put a 2 in the front. So I'm done writing the equation for dissociation. Now I can set up my picket fence. So they said if 3.6 moles of calcium hydroxide dissociate, how many moles of calcium ions will we have? So we're going to start with what they gave us, 3.6 moles of calcium hydroxide. And again, just like in the previous problem, where we will use the balanced chemical equation, okay? Just like we did with stoichiometry with the mole-to-mole ratios. So again, there's 1 mole of calcium hydroxide here, and that's where I'm getting this number from, the 1 that I'm going to put here, mole of calcium hydroxide. And they're asking me for moles of calcium ions. Well, this right here is calcium, and I only have 1 of those. So I'm going to write 1 mole of calcium, and again, that's an ion because it has a positive charge. Now, in this case, 3.6 times 1 divided by 1 will give you 3.6 moles of calcium ions, and you can have a situation where that will happen. And that is how you go about solving for a certain number of moles of a specific ion, or you could be solving for the compound given a certain amount of moles of the ion or a compound through dissociation.